Alright guys, so let's do this one where we don't put it into the ax minus h squared plus k form. Let's just do it directly. Can you tell me if this is going to open up or down? How do you know it's going to open up? The x squared piece has got a positive coefficient, so it's going to open up. How do I find the vertex without putting it into what they call vertex form? Yeah, the shortcut is the x piece is negative b over 2a. What's b? Negative 8, so it'll be negative negative 8, so it's 8 over twice a. So you get the x piece is 2. And the vertex is a point, of course. How do I get the y piece?
0.
No.
Divide
No. Plus 3, what do you mean? Now what would the 3 be? What would this be? Y-intercept. So here's the y-intercept. Y-intercept is 0, 3. Now, anytime you have an x value, how do you find the y value? Plug it in. So the y value would be f of 2. So that's 2 times 2 squared minus 8 times 2 plus 3. Is that cool? Just plug a 2 in. There's the function. Plug a 2 in. So 2 times 4 is 8, minus 16 is negative 8, plus 3 is negative 5. So the vertex is at 2, negative 5. What would the axis of symmetry be? X equals 2. Now, let's plot what we got. Let's plot what we got. We got enough information now, believe it or not, to plot this. Because I kind of give you a hint here. Mirror image. What I think the book calls the point of symmetry, which is really a pathetic name. So this vertex is at 2, negative 5. So 2, negative 5. The y-intercept is 0, 3. So where is there going to be another point? No. Where's the vertex? Here. One point is there. There's got to be another point over here, right? What's this dotted line I drew? It's called the axis of symmetry, and it's also known as the mirror. It's where the mirror is. So there must be a mirror image right there. How do I check that? Yeah, plug it in. Anytime I have a point that I think is on the graph of an equation, I plug it in and make sure it works. So this is what point is this? 4, 3. So this is the point 4, 3. If I plug a 4 in, do I get a 3 out? 2 times 4 squared minus 8 times 4 plus 3. 2 times 16 is 32, minus 32 is 0. Plus 3 is 3. Sure enough, when I plug a 4 in, I get a 3 out. So you can always double check that mirror image point. Because it comes from out of nowhere. So how do you trust it? Make sure it does what it's supposed to do. Make sure it works in the equation. That's what it is. So here's my little... You can make whatever sound effects you want. Now, if you had to... Stay with me now. If you had to estimate the X-intercepts, what would you say they are? You had to estimate them. What is this roughly? Right here. 0.2. I love it. So something you can say like a half, or it looks like it's a little bit closer to 0, so 0.2, 0.3, something like that, right? What about this one? 3.5, somewhere around there, right? Of course, my crappy curve. Well, let's see how close I got. How do I find the x-intercepts? Always. Make y0. To find the y-intercept, you make x0. To find the x-intercept, you make y0. It's crazy. Does that idea ever change? No. It's a fundamental idea. So I make y 0. Please solve this. Let me know when you're done. What's a really smart thing to use to solve that? Quadratic Formula?
There you go.
Use math. Class, somebody? Math. Use math. Make sure you can get the decimal approximations. Oh, shit. Don't have a calculator with you. Oh, shit. You're not going to be able to do that too often. So how does the quadratic formula get set up? What does it look like? 8, give or take. 64 minus 24. I love it. 4 times 2 times 3 is 24. All over twice 2. I like it. So it'll be 8, give or take, square root of 40 over 4. Just to cut to the chase, this would be 4 times 10. So this is 8 plus or minus 2 square root of 10 all over 4. Which is 2 plus or minus a half or root 10. I'll just do it like that. So if I plug those in the calculator, real quick, you guys see where that came from? You can't just go 8 divided by 4 is 2 and say 2 plus or minus 2 rad 10. 2 rad 10 is being divided by 4 also. 2 over 4 is 1/2. So let's see what we get. If I put 2 minus rad 10 divided by 2, I get that, which we guessed it looked like it's a little less than 0.5, so hey. And if I put second enter and make that a plus, which is a nifty trick, to plus that is the 3.5 that we thought was up here. So 0.4 roughly and 3.5 roughly, which matches up with what it looks like on the graph. Do you guys all see that? Is that decent? I'm going to take that as a yes. Pleasure. You guys would like to talk to me. Okay. And we already graphed the parabola, so that's a little late. Alright, so now, let's get into some new stuff. Let me give you guys some stuff. Oh my god. Where'd you go? There you are. Alright, so here's 11/8. Please, if you have to leave early, you might want to grab the practice test before you leave. I'm going to clear that up in a little bit. Guys, if I throw something, whee, what kind of shape does it take? Parabola. I love it. So the graph, if it's time versus height, the parabola that you graph actually mimics what that thing looks like. Okay, that's scary. So sometimes graphs actually look like the thing they're graphing looks like in real life. Especially if you have time versus position. You could be climbing a mountain and then you come down the other side. It looks just like what you were doing, right? Does that make sense? Okay. So a baseball is hit into the air. Why does it make sense that this first thing is negative? What is that ball going to do? It is going to go up, and it's going to come back down, thankfully. Or else baseballs would just be flying around the earth. How are you guys doing so far? So it makes sense that's going to be a down parabola. And what's really, really nifty is that 16 isn't just made up shit. That's actually physics. There's a certain number that relates to how quickly you lose velocity as you try to go up. So there's a certain velocity. Have you guys ever heard the phrase escape velocity? So if you have the right escape velocity, that means you escape the gravity of the Earth. So that first term being negative tells you that that's the Earth taking your velocity away. So at some point, at the very top, what happens to your upward motion? You're actually not moving up at all anymore. And then it starts to pull you back down. So that 16 is actually related to 32 feet per second squared. That's how quickly it's taking velocity away from you. You're not going to suddenly have to know physics. I just want you to know that that equation is actually valid. It's a truly physical representation of the situation. So let's see if we can work with this. So height h after t seconds. That's what's happening there. So what's the height of the baseball the moment it's hit? At the moment it's hit, how much time has gone by after it was hit? 0. I love it. So when it is hit means t equals 0. No time has gone by yet. So what do you get? What's the height at t equals 0? So h of 0, of course, is 3. That is also what we call the y-intercept. In this case, it would be the h-intercept. So when he hits that baseball, and baseball is one of the sports I suck at so bad. When I was in 6th grade or whatever, they called the strikeout, they call it the waller. Oh, you wallered that. Basketball is where I shone. Baseball, I hated baseball. I still do. I sucked at it so bad. Just to let you guys be my counselor. So when he hits the ball, it's 3 feet up in the air, which kind of makes sense, you know. So you can have somebody go chasing after one up here, go chasing after one down there, but 3 feet up in the air sounds about a decent height to hit that ball. So that's what that means. Is everybody with me so far? Even if you don't play baseball, you get the idea. After how many seconds does the baseball reach its maximum height? Okay, how the hell do I find that? What's that? Yeah, it's the vertex. I love it. So another name for the maximum height is the vertex. What is the quick way to find the vertex? Yeah, negative b over 2a. And now, is it going to be x equals negative b over 2a? No, it's going to be what's acting like x? What's the input? T. This axis is now time. So the input vertex component is negative b over 2a. What's b? 96. So negative 96. And what's a? Negative 16. I believe that's 3. Not mistaken. Could be mistaken very easily. Is anybody going to help me out? Is that 3? Okay. So that's 3 seconds later. That's when it reaches its maximum height. How do I figure out what the maximum height is? Plug it in. If I want to know what the height is at 1 second, I plug 1 in to see what the height is. 3 seconds is when it hits the max height, so I plug a 3 in to see what that max height is. Do you guys see what's happening? So, second. Plug a 3 in. Yep. The only equation. So, on a lot of word problems, when they ask you, what's the maximum profit? What's the minimum cost? What's the maximum height? What's the minimum areas? Whatever. That relates to finding the vertex of the equation that was given to you or that you had to set up, because they're word problems. Oh, shit. What is happening over there? All right. So what do you get when you plug a 3 in? Minus 16 times 9 is 9 times 16 plus 3. What is that, 147? 147 what? B. Yes. Please don't tell me the maximum height of the baseball is 147 seconds. How tall is your son? He's about 3 seconds tall.
Mr. Waller?
Yeah.
So would you do 3 squared first and then multiply that by 16?
Yep. Yep. What tells you to do that? Order operations. You exponent it before you multiply. Yeah. What's up? Everybody all right? What's up?
I got 144. Oh,
Maybe I'm wrong. I did it in my head, but somebody told me.
I thought you were just doing the first part.
Oh no, the whole thing. Sorry. Yeah. Okay. Oh. Okay. All right, guys. I'll tell you what. Before we do this one, you guys do number 3. That's the one that's sort of like the one we just did. And then we'll do the barn problem next. You guys try number 3. Now, to be totally honest, I can't tell you if that is an actual equation, but the equations that govern how much drug you have in your bloodstream do look like this. So it's always nice to see algebra equations being used in important situations, not just sitting in a classroom. Now, as you guys are starting to do this, can somebody please tell me, before you get into this, what is B?
Wait, no, sorry.
It's 0.06. Why is this one a little evil? Is it in order? What is A? It's the number that's in front of the X or T or whatever squared. A is in front of the squared term. B is in front of the letter by itself. And C is the number that's out there by the constant. So they just gave it to us out of order. Just because I change those, I don't change A and B. That doesn't make any sense. Let me change my equation and my baseball suddenly goes, whoa! No. I can't control. That would be neat. Control reality. No, I can't do that. When I was a little kid, I thought I could. Just to continue this divulging stuff today. I thought I could learn equations, change them, and then the reality would change. But I found out that's not true. So if I put this in order, this would be negative 0.0002 t squared plus 0.06 t. C is 0, it's not here, right? So I can use that same idea to find out the time when it reaches the max concentration. Why is it going to be a maximum, by the way, not a minimum? Which means this opens down, which means it's going to have a peak. I like it. I am smart. SMRT smart. What do you guys get? So it'd be negative what? Over twice, negative 0.0002. 1, 2, 1, 2, 300. I think it's 150. Did I do that? 2, 5, 1, 2. 1, 2, 1, 2, 1, 2. Yeah, it's 150. So T equals to 150 what? It's a different problem. You better reference the problem to make sure. So after 150 minutes, that's when it reaches the maximum amount in the bloodstream. What is that? So this is good. If you're gonna, especially if you're gonna go into pre-calculus or maybe even calculus. When I say when does something happen, that's an input. In this case, that's a T. When I say what happens there, that's an output. In this case, that's the concentration, the C. Right, so when does something happen is on the x-axis, or in this case, the t-axis. What happens there is the output. So when, after how many minutes, or when, what is that concentration? I just take 150 and do what with 150? Plug it in. I want to know what the concentration is at the time that I just figured out when the maximum occurs. So plug a 150 in. Let's see if I can. .03, 4.5. I'm just saying numbers. Is it 4.5? You'll find out, Jeff. Yeah. Is it? Really? Yeah. Okay. Don't humor me. Tell me if I'm wrong. I don't mind. If it is 4.5, then you can be a little impressed. That's okay. 4.5 what? Concentration is measured in milligrams per, what is that? Liter. I love it. Taking any chemistry, this is certainly bringing back some kind of memories. Okay, so let's look at this barn problem. Barn problem. The barn problem's right up there with Syria. So a farmer has 500 feet of fencing. He wants to use all of it to enclose this area and then divide it into 3 pens. Okay, he's going to put his orcs here and his hobbits here. You don't want the orcs eating the hobbits, obviously. To save on the amount of fencing needed, one side of the enclosure will be the farmer's barn. Now, all that just sounds like, what the shit's it got to do with math? But you're going to have 2 different kind of problems with this, and they're both optimization problems. Does that word make sense, optimization? If I want to know the maximum profit, I'm going to optimize my profit. The minimum cost, I'm going to optimize my cost. The maximum area, I'm going to optimize my area. You guys with me? What? You guys ever seen how they hold grain or peanuts or something? What do they hold those in? What shape are they? Cylinders. Stay with me. You're all like, what the hell? Because if you try to hold it in a box, like a just a box kind of shape, you would use more material to get the same volume. So that's kind of like the problem we're talking about, just on another dimension, to be honest. So what shape gives you the most volume for less material? Cylinders do. The circle, and then you just kind of can repeat the circle. So that's why a lot of those are cylindrical. It kind of depends on what you're putting in there too. But still. All right. This has nothing to do with cylindrical stuff holding grain, but it's the same idea. These kind of problems, either they give you an equation and you use the negative b over 2a stuff, or you have to make your own equation, in which case they are going to tell you something and then they're going to ask you something. What is the thing that they tell me here? They tell me 500 feet of fencing. How does that relate to this? So in a formula, what is it that they tell me? What is 500 equal to? That 500 is the fencing. I'm going to use the fencing to do all this, right? So how many y's do I have? How many y's? 1. Because what's this? Do I need to put fencing here? No, because I'm going to jut this up against my bar, right? Save some money on the fencing. So that's the fencing has to go along the y, and then I want to make these. So how many x's am I going to make? 4. So the 500 feet of fencing goes into making that y side and those 4 x sides. That's what they tell me. It's not really perimeter, but it's related to perimeter. Perimeter would just care about the outside. I'm caring about actually laying the freaking fencing down. I better include those interior ones. They don't just magically show up. Where's the magical inside fences? No, you got to put those things in there, man. So that's what they tell me. What is it that they ask me? What do they want me to maximize? What is it I want to optimize in this problem? What do I want to optimize? Look at the question. Say again? Find the dimensions that maximize the area. That's what I want to optimize. So they tell me information about length of fence, right? And they ask me about the area. What's the formula for the area of that? Now, please, dear God. All right, well. What's the formula for the total area? We could do this. XY. I love it. I remember there's a problem like the first semester I ever taught. And I said, you cut a board into 3 pieces, and 1 piece is twice as long. You guys kind of with me, that kind of problem? And the guy said, there's a guy in the back that's like, Mr. Waller, when you cut boards, you lose about 1/8 of an inch of the board in the teeth of the... I'm like, all right, dude. If you want to put that in your word problem, you can. We're cutting our board with lasers, all right? So you leave the hell alone. So I want you to understand, if I don't even know if anybody was considering this, but let's assume that the fence is like really thin, so it doesn't take away any of our area. We have to assume that. You guys kind of with me? So when you learn physics, you start with like frictionless tables and massless ropes, just to make the math easier. And when you get further along, you start to see how to change the problem, adding the actual reality. Ropes have mass. The tops of tables are not frictionless, thank God, or else everything would just be every freaking where. Right? So you start with the simplistic, and then you start adding in the hard reality. So here we're going to assume that these fences don't do anything. So what's the total area of this? It's just going to be x times y, right? So the area equals x times y. Okay. So I know this, and I want to investigate this. How do I use what I know to help me with this? What sucks about this equation? Yeah, there's no numbers, which really doesn't bother us that much because we're better than that, but there's too many variables, really. You know, like, I appreciate that, I think, but there's too many letters. Can I use this to help me eliminate one of the letters? Can I use maybe something like substitution? What can I do with this equation? How? You can't just plug it in. What do you mean? Plug what? If 500 is y plus 4x, can you solve for y? Can you solve for y? So y equals 500 minus 4x. Now what does the area look like then? Area is x times y. What's y? 500 minus 4x, so let me just plug that in here. So what's the area then?
500x.
So what kind of shape would this be? What shape would this take on if I graphed it? I'm not saying you have to graph it, I'm saying if I did. Probably, that's what we're studying. Can you guys identify A and B? What's A? Little a. -4. What's B? 500. Can you find what x value, in this case, what width, would maximize this? Now again, so we set up our own equation, but it's just like the concentration in the bloodstream one we just did. It's just like the hitting the freaking baseball one. They gave us those formulas, but what did we do? -b over 2a to find the vertex, because that's where the max or the min occurs. So we created this equation, but still, now I'm going to use it. Can I find the maximum? Yes, -b over 2a. So x equals -b over 2a. $25, 62.5. Maybe. Maybe. 62.5. 62.5 feet. And what is the question asking me for? Find x and y. Did we find x? Yay! How do I find y? I know that y is 500 minus 4x. X is 62.5, so what's y? 500 minus 4 times that. $250. So they told me something that I can write as an equation. The 500 feet of fencing go into making this side and those sides. They asked me something that I can write an equation for. And then I use what they tell me to help with what they ask me. You guys do number 4. I didn't even look at it too. Yeah, I like it. Let me draw you a little picture. That's just shoreline. And then now this one is, they didn't even give you a picture, so you had to make your own, so I helped you out a little bit. What are you going to call this side here? Okay, you can call it x, which means this is x, which means this is y. That's crazy. So they tell me something, and then they ask me something. Here, while you guys are doing that, let me pass out the practice test. So this, somebody pointed out that this does seem a little bit like the barn one. They said now it's going to be, they tell me that 200 equals y plus 2x's, because they don't have any of the interior stuff. Right, I'm going to put all the kids and all the adults and all the lab swimmers. I didn't do anything else. Everybody just goes all together in there. Huh? X squared? What? For what? Nothing. Yes. Okay. So what do they ask me to do? Area. And what's the area of this? That's crazy. So this is a nice one for you guys to start with, because it is very much like that barn one. The barn one's a little harder, to be honest. So what do you guys do next? Y equals. Y equals 200 minus 2x, is that cool? You use what they tell you in what they ask you. Alright, so you guys finish that out. Distribute that x, try to get the vertex. Oh, text mode. That's nice to know. So what's B? 200. So negative 200 over twice A goes in nice. So x is 50, therefore y, 50 what?
Meters.
Meters, there you go. Y will be 200 minus twice that, which is 100 meters. Sweet. All right. Not too evil. Yeah. All right. So everybody got a practice test, right? So Monday I'll have the answer key. Monday's review day. Tuesday's the test. I'll see a few of you guys in lab. In a minute, we're gonna have that quiz.